All right, we're taking a look at 5.2. In 5.1, we worked with multiplying exponents and just kind of like what happens with that, what are the rules. So just to look back, remember for these, we would take our bases, so like 4 times 4, and we'll get 16. And then we take our our common variables. So this is v to the first and v to the second, and we add 1 plus 2, and that's going to give us v to the third. Okay, so again, we could even, this is v to the first here, so we could take a look at this and we could say 2 times 2 times 3. So 2 times 2 is 4, times 3 is 12. And then we can look at v to the third, and v to the first. 3 plus 3 is 6 plus 1. So I'm adding these ones. 3 plus 3 is 6, plus 1 is 7. So we end up with v to the 7th, 12v to the 7th. Okay. In 5.2, we are learning a rule for negative exponents. So what happens if we have a negative exponent? Well, a negative exponent means it's in the wrong place. That the variable is in the wrong place. So if we think about, and these are going to be extremely simple, when we think about an expression, right, or if we're working with terms, we have x to the negative fifth and we have 4 to the first. So this negative 5 power is only attached to the x. This negative 5 power has nothing to do with the 4. It is attached to the x and only the x. If I jump down here a little bit further, 5 is its own thing. This is 5 to the first power. X to the negative fifth. So this negative 5 is only attached to the x, and y to the negative sixth is only attached to the y. And so when we have a negative exponent, it means that it is in the wrong place. So this x to the negative fifth is in the wrong place. And what I mean by that is in our fraction. So if this is all sitting over 1, any like whole number or any whole expression that you see, if it's not written as a fraction, it's technically sitting over 1. I'm going to write another fraction bar, and I'm going to go piece by piece. So my 4 doesn't need to move. He's happy where he's at. But this x to the negative fifth is unhappy upstairs. And so what happens is if I take him and I move him downstairs, so this is negative fifth, x to the negative fifth. This is x to the positive fifth. So as soon as it crosses that fraction bar, it becomes positive because now it's happy. It's in the right place. So let's take a look at number 2. This is all sitting over 1. So if I were to rewrite over here, my 6 is fine. He doesn't need to move. But this x to the negative fourth is unhappy there. So I'm going to write it downstairs, and that's going to make it happy. Now it's positive 4. All right. So in this one, we have n to the negative sixth. So this is all sitting over 1. And the only term that we really have here is this n to the negative 6. So we're going to need to write him downstairs to make him happy. So now it's n to the positive sixth. But I need a placeholder. So if I have nothing to write down, I can just write a 1 as a placeholder. Okay, so number 4, the 3 is fine where it's at because that's its own thing. The b to the negative first is unhappy, and so it needs to be moved to become positive. Okay, let's take a look at that have like doubles going on here, some multiple terms. So again, this is all sitting over 1. And I'm going to move piece by piece here. So I'm going to take a look at my 6 first, my whole number. 6 doesn't need to move. M to the 5th doesn't need to move because it's positive. It's happy where it's at. N to the negative 6th does need to move to make it positive. So 6 stays, M to the 5th stays, N to the positive 6 now because we moved it. We took this. When it moves down, it becomes positive. Now it's happy where it's at. So a negative means it's unhappy where it's at, and a positive means it can stay. It's fine where it's at. So here we go. 5. Remember, this is 5 to the 1st. So 5 does not need to move. X to the negative 5th needs to move downstairs. Now it's x to the positive 5th. Y to the negative 6 needs to move downstairs. Now it's positive. Okay? 6, happy where it's at. X to the negative 6th needs to move. It's unhappy where it's at, so I need to move it downstairs to make it positive. And then y to the 4th is positive. It's happy where it's at, so it does not need to move. So if you notice, all we're doing is we're moving things that have a negative exponent attached to them. So for this one, u to the negative 5th is not happy where it's at. It needs to move downstairs. So now it is u to the positive 5th. And then I don't have anything to write, so I'm going to write a 1 as a placeholder. All right. So we're looking at this piece by piece by piece. So remember, 4 is its own thing. That's 4 to the 1st power. X to the negative 3rd, that negative 3 is attached to the x. Y to the negative 2nd, that y is attached to the, or that negative 2 is attached to the y. And z to the positive 2nd. So you see I have 4 different colors here for my 4 different terms. I have 2 colors that need to move. The 2 colors that need to move are my orange and my green. So 4, my purple 4 can stay, and my blue z to the 2nd power can stay. Those are going to stay up top because they're both positive. Positive exponents. I have negative exponents on my x and y, which means they need to move downstairs. They need to move. So now this is going to be x to the positive 3, y to the positive 2. They're happy now. So a negative exponent just means it's in the wrong place. And we're going to see sometimes we have negative exponents in the bottom, and that means they need to move up. But for right now, we're just kind of taking a look at what happens if they're all above 1. So 5 is going to get to stay. A to the negative 6 needs to move. That's going to make it positive 6, though. B to the 3rd gets to stay because it's positive. And C to the negative 6 needs to move to make it positive. So I had 5 and B to the 3rd. Both of those guys could stay. A to the negative 6 needed to move downstairs. Now it's positive. C to the negative 6 needed to move downstairs. Now it's positive. So it just changes the sign. All right, and I'll do these last couple here. Yeah, there's just lots of examples. I'm not going to take all the time to do all of them. So this is sitting over 1. And the idea is that we, instead of having to color coordinate, at some point we're going to be able to just look at this and say 6 is going to stay there. M to the negative 1 needs to move down. Now it's positive. P to the 6 can stay where it's at. Q to the 3rd can stay where it's at. However, whatever way helps you organize. So here again, 3 can stay. X to the 2nd can stay. Y to the 3rd can stay. Z to the negative 6 needs to move down because he's unhappy. Now it's Z to the positive 6th. Okay. I'll just do the last two here. I'm going to do 35. So again, without color coordinating, I'm moving piece by piece. I have this 3 can stay. H can stay. This is h to the first. Okay, so if we don't see anything attached, it's just a 1, so h can stay. J to the negative third needs to move down. K to the second can stay because it's positive. And then 36. We have 6 can stay. A to the fourth can stay up top. B to the sixth can stay up top. C to the negative second needs to move downstairs to become positive. So we're just moving those things. So let's take a look now. I'm going to add another concept in, which is when we move these, sometimes, so like this m to the negative second is unhappy. So check this out. We know that m to the negative second, which I'll highlight in purple, needs to move. 3 in orange gets to stay where it's at. It's happy in the bottom. There's no negative exponent attached. And m to the positive fourth in green here is also happy downstairs. So we're going to leave him down there. So here's what would happen. I have 3 is happy where he's at. Doesn't need to move. I also have m to the fourth is happy. Doesn't need to move. But my purple m to the negative second is unhappy and needs to move downstairs. Now it's m to the positive second. And this is all sitting under 1 now since this moved and there wasn't really anything else up top, okay? So check this out. I have m to the fourth. These are all multiplying. Everything's multiplying here. So I have 3 doesn't change, but I have m to the fourth. Remember, that means m times m times m times m. This is drawing on last lesson. I also have m to the second, which means m times m. So I have a total of 6 m's that are multiplying with each other. So I can say m to the sixth. So I'm just simplifying this and putting my 4 and my 2 together. 4 plus 2 makes 6, just like we learned last time. So check out number 6. We have 2 over 2. Now we're going to learn more about kind of the dividing rules. So I'm not going to mess with reducing or anything like that just yet. I have B up top, which is happy. He doesn't need to move. But in blue down here, I have B to the negative second, and in order to make that positive 2, I need to move it up. So I have B1 and B2. So that really means we're going to have 2 over 2, and B to the first and B to the second is going to give me B to the third. Remember, we're adding these. There's some other rules when we have positives and they're opposite of each other, but for right now, I just want you to see that we can move our negatives, and if there's something already down there, then they just get added up. So I have 4 over 4. Again, I'm not going to reduce that. That would be 1 over 1, but the focus of this video is to show you if I have a negative 4 up here, I'm going to need to move it downstairs to make it positive. If I have a positive, it doesn't need to move. So x squared doesn't need to move. X to the negative fourth needs to move to become positive. And then my x squared times x to the fourth is going to give me x to the sixth. Okay? So, again, I'm looking. N to the third is fine where he's at. Doesn't want to move. 4 is fine where it's at. Doesn't need to move. But this n to the negative second is not happy where he's at. And in order to make that positive second, it needs to move upstairs. So this is now n to the positive second. And then think about when we simplify, I have 3 plus 2, which makes 5, and it's over 4. Okay, let's look at these last 4. They're kind of more complicated, and we're going to move some things around. So check this out. I'm going to do lots of color coordinating. A to the positive second is going to stay where he's at. B to the negative first, I'm going to bring downstairs. 3 is going to stay downstairs. A to the negative first needs to go upstairs. He's unhappy. And B to the second is happy where he's at. Okay, so color coordinating again. I'm looking at my orange A to the second, stays where it's at. My red B to the negative first needed to move downstairs to become positive. My blue 3 stays where he's at. My purple A to the negative first needs to move upstairs to become positive. And my green B to the second needs to move downstairs, or needs to stay. So here we go. Now we're just going to clean this up. A to the second and A to the first gives me A to the third. My blue 3 stays how he is, and B to the first and B to the second gives me B to the third. We're going to skip that one. Okay, let's look at this one. So 3 stays where he's at, B squared stays where he's at, A squared stays where it's at, and this B to the negative first needs to move upstairs because this negative 1 means it's in the wrong place. So I move it upstairs to put it in the right place. And then I'm just simplifying. So 3 times, it's going to give me B to the third over A to the second. All right, and this will be our last one. I'm not going to worry about reducing 4 divided by 4 to make 1 over 1. Okay, x to the negative third needs to move upstairs. So I had x to the second, which is happy where it's at, times x to the positive third now that I've moved it. Let's see here. I also have y to the second, which doesn't need to move. And then y to the negative fourth needs to move downstairs to make it positive. Now it's y to the positive 4. So once you move everything around to give you positive exponents, then you can go through and simplify. And you could do it in your head too. You could think, well, there's 2 y's downstairs and I move 4 more. And you could jump to just say, well, that's going to give me y to the 6th down here. Or I had 2 x's upstairs and I moved 3 more upstairs. That's a total of 5. X to the 5th upstairs. And we have 4 over 4. The other way to think about it would be just to write it and then calculate it. Write it out and then calculate it.